In this video clip, I am going to explain further on the different techniques using with encryption algorithm. As stated earlier, there are two different types of encryption algorithm. There are the symmetric and the asymmetric algorithm. In both methods, a key is needed. A key is used to encrypt a plain text to a cipher text for data security once transmitted online. This is possible if both parties, the sender and the recipient, must have the same key for encryption and decryption of data. The sender will needs a key to encrypt data into ciphertext. The recipient will needs the same key to decrypt the ciphertext back to the plain text. During transmission of the ciphertext, the sender needs to distribute that key together with the ciphertext to recipient. Once recipient receives the ciphertext together with the key, it is possible to decrypt it. What is the problem here? During the distribution of the key, it can endangering the key itself. A hacker may tap into the systems during transmission and intercepted with the key. This is somehow insecure the ciphertext, too. This condition is called key distribution problem. There are techniques used to solve this problem. 1. It is by using the symmetric encryption routine or algorithm. It is not involvement in sending and receiving of key electronically. As an example, Step 1. A sender uses an encryption algorithm and choose key equals 2. The recipient is also using the same algorithm and define a key equals 4. Step 2. The key x equals 2 is placed in a simple algorithm calculated by 7 the power x mod 11. The function mod gives a remainder after division. 7 the power of 2 equals 49. Mod 49 with 11. You get a remainder of 5. The recipient will perform the same calculation with the same algorithm. 7 the power of 4 equals 2401. Mod it with 11. You get a remainder of 3. In step 3, the sender now sent that key value equals 5, which is the remainder. The recipient will also send the key value equals 3, also a remainder. Both parties are exchanging the keys. In step 4, both sender and recipient will perform a calculation using the same algorithm. The sender uses the key equals 3 and applies it to this algorithm. 3 the power of x, which is 2. From step 1. Mod with 11. This gives 9 mod of 11. The remainder is 9. The recipient applies it to the algorithm. 5 the power of 4, mod with 11. 625 mod 11 equals 9. It is exactly value 9 for both. Thus both sender and recipient end up with the same encryption and decryption key of 9. This gives us the basis of how an encryption key can be generated. Probably later of the day, the sender will send the ciphertext to be decrypted by the key value distributed here. In this video clip, I am going to explain further on the next encryption algorithm. It is called the asymmetric algorithm. As mentioned earlier, both of these methods are involving transmission of ciphertext, which is encrypted by a special key. The risks surrounding symmetric encryption keys have been already discussed in the earlier video. Here, there is a more secure method. It is called asymmetric algorithm, or simply using a public key encryption. In this method, it is using two keys. One is the public key, and second is called the private key. The public key is distributed to everybody in the network. The private key is only assigned to individual computer user. How is asymmetric encryption used? Remember, it involves two different keys in this method. These keys are generated using a special algorithm, which is called A hashing algorithm. Here, the sender will use the hashing algorithm. It will take a key and translates it into a string of characters. This string is in terms of hexadecimal notation. With hexadecimal notation, makes the key more secured and impossible to read or interpreted by hackers. The same hashing algorithm is also applied at the other end, that is, done by the recipient. These hashed string keys are then used to encrypt and decrypt the plain text to ciphertext, as well as the ciphertext back to the plain text, by both users in the network communication. With hashing algorithm used for the keys, it is virtually impossible for hackers to intercept with them. There are some hashing algorithm available on the internet. A well-known hashing algorithm, it is called MD4 hashing algorithm, or MD5. You may refer your textbook on page 107. The hashing algorithm, as you have watched a video on this, it is used within the authentication method. This method is used in digital signatures. In this video, however, I will try to show you the general steps of using hashing algorithm. The simulation below shows you how it works. Step 1. User A has a plain text. User A will encrypt it using a symmetric private key. Step 2. User A then will encrypt that symmetric key using the public key, which is known to both user A and user B. Step 3. User A will start sending both the ciphertext and the hashed cipher key. Step 4. Once user B received that message, user B will first decrypt the hash key. This is using the private key, which owns by user B. Step 5. That decoded hash key is now used to decrypt the ciphertext sent by user A earlier.